Okay, let's take a look at Atwood and ramp work problems. So we have an Atwood machine set up like the figure to the right. If mass 1 is 20 kilograms and mass 2 is 30 kilograms, what is the acceleration of the system and the tension in the rope? The first thing we need to do is we need to decide which way this machine is going to run. Since mass 2 is greater than mass 1, we know it's going to go in a clockwise fashion. So that's the first step. So first step is always finding the direction of movement. Second step, we need to draw a free body diagram for each one. So let's take a look at mass number 1 first. So mass 1, okay, it's over here. We know mass 1 is 20 kilograms. We know it has a tension up. We know it has mass of gravity, or force of gravity, excuse me, mass times gravity, which is 20 times 9.8, which is 196 newtons going down. The second free body diagram, very similar, 30 kilograms. We have an equal force of tension going up, don't forget, because tension stays the same, but now we have a greater Fg. And that equals mg, which equals 30 times 9.8, which is equal to 294 newtons. Okay. Now the last thing we need to do is we need to set a positive. We know mass 1 right there is going to go upwards, so let's set up as our positive. We know mass 2 is going to go downwards, so let's set downwards as our positive for mass 2. It's going to make things a lot easier. Now the third step is we need to create our equations for each one. So let's create our equation for mass 1. So now we have Newton's second law, which states that the sum of the forces equals mass times acceleration. Well, now the sum of the forces is going to be the force down and the force up, tension. Now we know tension is greater than Fg, so let's say sum of the forces is going to be tension minus Fg, and that's going to equal Ma. Now tension is just T because we don't know what tension is. Fg is Mg, and Ma is Ma. So we have tension minus mass times gravity, which we already know is 196, equals 20 times A. Now we're going to find what T equals to. T is going to equal to 20A plus 196. For our other equation, very similar. Sum of the forces equals mass times acceleration. Now this time Fg is going to be larger, so let's say sum of the forces is going to equal to Fg minus T, and that's going to equal to Ma. Fg we found out was 294, so we say 294 minus T equals 30A. Okay. Now the next thing we need to do is we need to, isolate T, which we did. That's right there. And we're going to sub T into equation 2. So let's do that over here. Let's say sub T, because we know T equals that. So sub T into equation 2. And we'll say that's equation 2, and that's equation 1. So when we do that, we get 294 minus now T is 20A plus 196 equals 30A. Simplify this a little bit, expand it out. 294 minus 20A, because that minus you need to multiply through by there and by there. So minus 196 equals 30A. We can simplify further. We get 98 on the left-hand side. We get 50A on the right-hand side. Divide each side by 50, and we get A equals 1.96 meters per second squared, clockwise direction. Now the next step is we need to sub A into one of the equations. Let's pick equation 1. So we'll say sub A into equation 1. And we're going to do that to find T. So there's our answer for A. So we're going to say T is equal to 20 times 1.96 plus 196. And that's going to give us a T value of 235 newtons. There's our answer for T. Two masses, 4 kilogram and 6 kilogram, are connected by a massless rope over a frictionless pulley, as pictured in the diagram right there on the right-hand side. The ramp is inclined at 30 degrees, and the coefficient of kinetic friction on the ramp is 0.18. A. Draw a free body diagram of both masses. So A. So our free body diagram for the first mass, so right there. Let's put it on the ramp. Okay. We know it's going to have a force of tension that way. It's going to have a force of friction that way. And to finish off, we know we're going to have an Fg there, which we can break into components there and there. We also know we're going to have an Fn. That's going to go in that direction. Now that Fn is going to equal to that right there. Now we know this angle is 30 degrees. So we know the vertical component is going to be Fg cos 30. And we know the horizontal component is going to be Fg sine 30. Okay. And that's going to make up the other force going in this direction. So this blue is going to equal to this blue line right there. It's going to represent the same thing. So that's equation 1. Or free body diagram 1, excuse me. Free body diagram number 2 is much simpler. Simply our 6 kilogram mass. We have an Fg down, which is equal to mg, which is equal to 6 times 9.8, which is 58.8. And we have a force of tension going upwards. Now we know the motion of this. Okay? We know it's going to go in the clockwise direction again. And we know that because this mass here is bigger than that mass there. Assuming it's moving, it's going to move in the clockwise direction. So we're done A. B. Determine the magnitude of acceleration for the system once it begins to slide. Now we know this, it's the same as we did before. Okay? So we're going to need to make both equations. So let's make them right here. We're going to say the sum of the forces. In equation 1, we know tension is going to be bigger because it's going to go to the right. And let's not forget our direction, positive. and direction positive. It's going to be tension, because that's the big one, minus force of kinetic friction, because that's working the other way, minus this guy right there, because it's going left as well. So minus Fg sine 30. Now a couple side notes here. We can simplify this equation. We know Fk. We know the equation for Fk is going to be Fn times mu. Now Fn is this guy right here. We just said that that guy is equal to that guy. So we can say that Fn is equal to Fg cos 30 times mu. Fg we know is mg, so mg cos 30 times mu. The mass is 4, so 4 times 9.8 cos 30. And we know mu is 0.18. Running out of room here. Anyways, when you do all that, you get an FK value of 6.11. Okay, so just one more time, I know it's a little hard to read. It says 4 times 9.8 times cos 30 times 0.18. Supposed to be a bracket there. And a bracket there. 0.18. And that gives us 6.11. The other thing we need to know what this Fg sine 30 is. So let's do the calculation over here. Fg we know is mg sine 30. Okay, and when you do that, you get 19.6. So let's plug those numbers in over here. So now our sum of our forces is going to be T minus 6.11 minus 19.6. And that's going to equal to M, which is in this case 4, times acceleration. Now we can simplify this. 6.11 and 19.6 give us 25.7 and 4a. And isolating for t, we get t equals 4a plus 25.7. The second equation here is a little simpler. Sum of our forces, ma, we know Fg is bigger, so we're going to say 58.8 minus t equals 6a. And now we're ready to substitute. We can substitute our t value, which we got right here, into this t value there. So let's try that. Let's do 58.8 minus 4a plus 25.7 equals 6a. We simplify that, and we get 58.8 minus 4a minus 25.7 equals 6a. Let's bring that up there. Left hand side we get 33.1 equals 6a, excuse me, 10a. 10a, because we have 6 plus 4, and then we get an a value of 3.31 meters per second squared, clockwise. Now what we're going to do is we're going to substitute that value into equation number 1 to find t. So let's do that. So t is going to equal to 4 times the number we just found, 3.31, plus 25.7. When we do that, we get a t value of 39 newtons. And that's our second value. So that's our answer for t. T equals, and our answer for a is right there.